All right, in this segment, let's look at the liver. Liver is a very large organ that occupies the upper right and middle portion of the abdominal cavity and is also going to be very important for metabolic and hematologic regulation, as we'll see. So it's covered by the visceral peritoneum. It has a fibrous capsule, and it has four lobes, which we'll see in just a moment. Here, we're looking from the feet up. So we're looking at an inferior view of a transverse section. So we can see the right lobe here, we can see the left lobe here, we can see our lesser omentum right here, our falciform ligament right here. Just to orient you, here's our sternum, our costal cartilage is here. Back here, we have our vertebral body and our spinous process. So that just gives you an idea of where we are. You can see the stomach here. You can see sort of the rugae within the stomach. You can see the spleen over here. So this is just to orient you. The liver is quite a large organ and takes up a good portion of the upper right part of the abdominal cavity. All right, so let's look at the lobes. We have our right lobe and our left lobe, and we can look at it underneath as well. Then you can see the other two lobes. You can see the quadrate lobe anteriorly and the caudate lobe, caudate meaning tail, being posteriorly, and you can see our gallbladder right here, which is about right here. Here's our falciform ligament. You can see it here as well. And that shows you the anatomical organization of the liver. The liver gets quite a bit of blood supply. It gets about 1/3 of its blood supply from the hepatic artery proper, and 2/3 of it comes from the hepatic portal vein, which is actually bringing nutrients from. A lot of the nutrients are coming from the small intestine. We're also going to be receiving some blood from the esophagus, stomach, and a lot of the large intestine. Now, 25% of cardiac output will actually go to the liver, so this is a very large percent. So let's look at the organization of the liver histologically. We have what are called liver lobules, and these are the functional units of the liver. And according to our book, they're about 1 millimeter in diameter and about 100,000 liver lobules, and each one sort of separated by little connective tissue partitions. And we're going to have, they're almost hexagonal, they're polygonal in structure. And typically we have 6 what we call portal areas, and these are called portal triads because, as you will see with their structure, we're going to have a branch of the hepatic portal vein along with the branch of the hepatic the hepatic artery proper, and we're going to have a branch of the bile duct. And these liver lobules are where most of the function of the liver takes place. And the liver lobules, they've cut them away here, but they're filled with these sinusoids. And remember, our sinusoids are there are blood vessels with endothelia. They're very gappy, so things can get in and out. Because remember, we're going to be producing plasma proteins here. And we're going to be producing other things here that we need to put into circulation. This is also where a lot of filtration is going to happen. So this is where we're going to get rid of toxins and wastes. We're going to remove excess things from circulation. We're also going to have some specialized cells, some special macrophages called Kupffer cells. They're going to be patrolling this area. And they're going to be looking for pathogens. So we're going to have pathogen presentation and phagocytosis here in the liver lobules as well. So here's our little connective tissue partitions. Here are our liver lobules. Each one of these, they're filled with these sinusoids. They have portal triads, portal areas, right at each vertex of our polygon. And that vertex, that portal triad, is going to consist of the part of the hepatic portal vein, the hepatic artery proper, and a bile duct. And you'll see all these little things coming to the bile duct. These are going to be coming from these areas, these little tiny bile canals that we call bile canaliculi. There we see that word canaliculus again, little canal. All right. So as we've said, there are these Kupffer cells. These are extremely important. These are phagocytic, and among other things, they will destroy pathogens. They will also get rid of things, scavenge things like heavy metals and iron and things that you really don't want in circulation. And we're going to see that the hepatocytes are the cells of the liver, the main cells of the liver. So each one of these little guys here is a hepatocyte. And we'll zoom in on it a little bit. And then we have our passageways for our sinusoids here. And here we're zooming in close up on them. Here we can see those sinusoids. Here's a Kupffer cell. Here's some bile canaliculi. each one of these is a hepatocyte. And remember, the functional unit of the liver is going to be the liver lobule, which is composed of these things, these portal triads, these hepatocytes, and these sinusoids. And here are bile canaliculae. All right, so one of the things that the liver does, obviously, is secrete bile, and that's going to flow through the bile canaliculae into the bile ducts, and we'll see there's a left and right hepatic duct coming from each lobe, left and right lobe of the liver, and those will merge into our common hepatic duct. But before they do that, there's going to be the common hepatic duct. There's going to be a segue or another bile duct that leads to the gallbladder, and that bile duct is called the cystic duct. And this is where, once the liver has made bile, that bile will then be stored up in the gallbladder where it's concentrated and dehydrated. So here we have our hepatic ducts coming from each lobe of the liver. So we've got a left and right hepatic duct, and then we've got our common hepatic duct. Then we're going to have the cystic duct. Some of the bile will flow up through here and be stored within the gallbladder, where it will be concentrated, dehydrated, and then can flow back out the cystic duct, where the common hepatic duct and cystic duct will join to form the common bile duct, which, as we know, will empty out into the duodenum. Now, let's look at the gallbladder for a second, because this is kind of important. First, let's talk a little bit about the structure of it. Well, it's the sac here that sits nestled in the inferior surface of the liver. We have a fundus, which is that dome shape. As we've seen, we have a fundus in the stomach. We have a fundus of other organs that have this kind of dome shape. Then we have the body and we have the neck, and the neck is where it attaches to the cystic duct. All right, so what happens is the liver is going to secrete bile, about 1 liter a day. And then we're going to have that bile emptying into our left and right hepatic ducts. Some of that's going to go back up the cystic duct into the gallbladder, where it will be concentrated. And then remember our cholecystokinin. When that's released by the duodenum, that's going to cause our gallbladder to start contracting, and that will send some bile down the cystic duct and down the common bile duct. And then we're going to have the opening or relaxation of the hepatopancreatic sphincter here at the duodenal ampulla, and that's going to dump the bile into the contents of the duodenal lumen. And what does bile do? Well, it emulsifies fat. And as we've said before, fat comes in these big droplets, and so it has to be emulsified by our bile salts, our bile here, which will then break up the big droplets into little droplets, because our lipases, our enzymes that break down fat, are not fat soluble. So we have to expose as much surface area of the fat droplets as we can to our enzymes, so that the lipids can be broken down. The gallbladder usually contains between 40 and 70 milliliters of bile at any particular time. And the bile is concentrated in the gallbladder, so that means it's dehydrated, and the salts will become much more concentrated, the bile salts. And this can become problematic because sometimes they'll form little hard crystals, little hard deposits that will get lodged in the gallbladder and can form gallstones. And if the condition gets bad enough, then in some cases, the gallbladder might actually have to be removed. All right, so we've got several functions of the liver. We've touched on several of them, or a few of them. One of them is metabolic regulation. This is going to be our nutrient storehouse, warehouse. So this is where we're going to store excess nutrients. We're going to let nutrients into the blood supply that maybe are in scarce supply. We're also going to have immunological regulation. So we know that we're going to be monitoring blood. So we're going to have a lot of blood flow through the liver. And so we'll be able to pick up pathogens there. We'll be able to pick up red blood cells that are nearing the end of their lifespan. We'll be able to produce our plasma proteins here, very important. And then we'll have our bile production. Now, if we look a little bit at the metabolic regulation that the liver does, it's going to adjust the composition of circulating blood. So what nutrients are in it? So a lot of the macromolecules that we absorbed, or I should say digested, into micromolecules that are then absorbed, and most of them are brought through the hepatic portal system to the liver from the intestines. Those nutrients will then be stored in the liver. So the liver is going to act as a filtration system, and it's going to catalog everything that we have. What do we have? What do we need? So anything that we have excess of will be stored in the liver, and anything that might be in scarce supply that we don't have much of in circulation, the liver will release its stores into circulation. We're also going to have some metabolism of nutrients, so we can build, for example, glycogen out of glucose molecules. We can also make cholesterol, an important lipid that, as we know, is going to be important for our cell membrane structure, as well as for the production of bile, for example. We're going to have some waste product removal. As we said before, nutrient storage. Anything that we have excess of, we'll usually put in storage. And we'll also have drug inactivation in the liver. All right, so when we look at the composition of circulating blood, it's going to come into through the hepatic portal system, and there it flows through those sinusoids. And we're going to have lots of cells in there. The hepatocytes, the Kupffer cells, they can monitor that and sort of act as a filter here. So toxins, heavy metals, iron, this kind of stuff can all be extracted from the blood and either stored, deactivated, or what have you. So the liver is very important for deactivating toxins or storing toxins and getting rid of things that we really don't want in circulation, as well as correcting for nutritional deficiencies by mobilizing these stored reserves that it has there. And by the same token, it might be storing things that we're eating in excess. We're also going to have our hematological regulation, which is quite important. So not only does it sort of balance our nutrients in the blood supply, but it's going to take things out of blood supply that we don't need. And it's also going to filter the blood in a way where it finds, for example, old red blood cells that are falling apart. Remember when we looked at hemopoiesis, that one of the things the liver does is going to take apart the components of those blood cells that have been destroyed or that have reached the end of their life cycle and have been phagocytized. A lot of them will be phagocytized in the liver, and then we'll have to, of course, disassemble our hemoglobin and store the iron molecules and that sort of thing. So the liver gets quite a bit of output from the heart. So it receives about 25% of cardiac output. And when you think about it, that's quite a bit. And the liver is the largest visceral organ, but nevertheless, when you consider the fact that it's getting 25% of cardiac output, that's quite a large amount. When we consider the hematological regulation of it, well, we've seen our Kupffer cells, so there's going to be phagocytosis. We're going to have some antigen presentation within the liver. We're going to have our synthesis of plasma proteins, removal of excess things like circulating hormones and antibodies. We're going to remove some of our toxins and store some of our toxins. So, for example, when hemoglobin is broken down, the iron is taken out of it, and the biliverdin, which will eventually be converted to bilirubin, will be used for the synthesis of bile.